Hi, and welcome to this extra video for Chapter 3. I know it's a big chapter, and this exam does give people a lot of trouble sometimes. So I thought I would do some big picture stuff to try to help you work through this chapter. So we've got multiple layers of function information to sort through. So I thought I would start with that. So at the top is the function that we're the most interested in. This is our original function. Oops. And this is the function that when we plug into it, we get out a y value. And a y value meaning if we need an x, we've got an x and we want to get a y value, we would plug into the original function. And what is a y value good for? We use a y value to locate a point. And what does that mean? Well, if we have a graph of some kind and we've got an x value, where do we put our point? We know how far left or right to go if we're given an x. The y value tells us how high or how low to go. And when is that useful? Well, with our max-min work. We like to know how high is a max, how low is a min. And so that y value is really useful for that. It's particularly useful when we're looking for absolute max and absolute mins, because that highest y value is our absolute max. The lowest y value is our absolute min. Okay, so to summarize, f of x, we get y values. We locate points with using the x and y values, and then we use those y values to determine absolute maxes and mins. All right, the next level of function that we know about now is the first derivative. We used to just call it the derivative. Now it's only the first derivative. And its main purpose is to give us information, give us slopes, instantaneous or tangent slopes. Okay, get used to get instantaneous rates of change or tangent slopes. And then what have we been doing in chapter 3? We have been making those sign charts. So, we solve f prime equal to 0 to get critical values. Let's start with that. And then we analyze using a sign chart to determine increasing, decreasing, and therefore identify relative max and mins. Let me write some of that down. So solve f prime equal to 0 to get critical points. So we can make a sign chart for f prime to determine the intervals where f increases or decreases. And then again, the max-min stuff. So I wrote, use the sign chart to identify relative max-mins. So again, to summarize, f prime is the first derivative. We use it to get tangent slopes, instantaneous rates of change. We solve f prime equal to 0 to get critical points. We make a sign chart to determine intervals where f is increasing or decreasing. And then that same sign chart will identify relative maxes and mins, because if you've got a positive derivative followed by a negative derivative, then you've got a max. And if you've got a negative derivative followed by a positive derivative, then you've got yourself some kind of a min. All right. Then we go on to our second derivative, f double prime of x. And that's as far as we go in this class with determining information from these derivatives. And the main use of the second derivative is to determine concavity. So we'll use the second derivative to determine intervals where f is concave up and or down. And when we solve the second derivative equal to 0, we get hypercritical values. And then instead of identifying max-min stuff, which you can do by putting stuff together, I'll get to that, but the equivalent down here, so we had critical values for the first derivative, hypercritical values for the second derivative, and then the analogy for the max-min stuff is the point of inflection idea. Okay, so second derivative gives hypercritical values. Then we can make a sign chart like above, but this time to determine concavity. positive second derivative is concave up, and a negative second derivative is down, concave down. Okay, and if you're at a point, a hypercritical value where it's neither concave up nor down, it's got a second derivative of 0. If the concavity changes at a point from concave down back to concave up, all right, if that change happens, or it could be concave up changing to concave down, if you've got that activity, that's a point of inflection. So those are the 3 derivatives in isolation, looking just at y values, just at slopes, just at concavity. We can go just a little further and put the first and second derivatives together. And that's where, first of all, there's the interpretation. I won't go through it all, but that's the increasing at an increasing rate, etc. I'll just say etc. And the key idea there is check the sign of the first derivative. That'll tell you the increasing, decreasing, right? And then it's all about, does the sign match between the 2 derivatives? So do the questions, do the 2 derivatives have the same sign or not? If it is the same sign, then whatever is going on, whether it's increasing or decreasing, same sign, it's doing it at an increasing rate. Opposite signs, it's doing it at a decreasing rate. So this might overcomplicate things, but you can make a sign chart. So for example, if the first derivative is positive, then we know we're increasing. And if the second derivative is also positive, then we're increasing at an increasing rate. If the first derivative is positive, we're increasing, but the second derivative negative, that would be at a decreasing rate. And if the first derivative is negative, then we would start off by saying, oh, f is decreasing. And then if we go to a positive second derivative, opposite signs, that would be decreasing at a decreasing rate, and then decreasing at an increasing rate when we go back to having the same signs. And increasing at an increasing rate, increasing at a decreasing rate, decreasing at a decreasing rate, decreasing at an increasing rate. So that's huge. All this stuff is so complicated and mind-numbing with the details. So keep working on that. And then one last little piece I'd like to talk about in this video is back to the max-min idea. And that's the first and second derivatives together with talking about max-mins, relative max-mins. And the idea here is fairly quick, right? If the first derivative is equal to 0, that has to be true at a critical value. In order for there to be a max-min in the first place, a relative max-min, we have to have a critical value. So picture a point with a horizontal tangent. We've got a horizontal tangent, so the first derivative is equal to 0. I know what I'm doing. And I'm going to draw 2 pictures. So here's another one. Here's another first derivative equal to 0 at a certain point. Then I'm going to look at my second derivative at each of these points. And let's think about it. If the second derivative is negative, that means concave down. So we've got a graph that's concave down, but is also momentarily horizontal tangent at that point. So the only way to have concave down behavior along with a horizontal tangent, that would be at a max. So these 2 pieces of information together, the first derivative 0, second derivative negative, gives you a max. And then on the other graph, if we have a first derivative equal to 0, so that horizontal tangent, and then the second derivative positive, so that we're concave up, picture that on this graph. So a concave up graph, upward view, at that moment when it's at a tangent line equal to 0, then we have a min. So this combination, first derivative 0 and second derivative positive, gives us a min. So this information here, this is all called the second derivative test, which our book does not emphasize much. It does go through it a little bit, but mostly we focus on the first derivative test, which is just the sign chart, increasing, decreasing, stopping there. You are welcome to use this second derivative test when you can easily find the second derivative. So, oh gosh, I lost a little line here. The second derivative here, that should be second derivative. So when the second derivative is easy to get, then you're welcome to use it. You just plug in your point, your critical value point, and check to see if it's positive or negative. All right, I'm going to wrap this up. I hope those little bits and pieces are helpful to you, and we'll keep working this week.